Welcome to Computer Science A-Level. The course is split into three different sections. Unit 1, Computer Systems, which is worth 40%. Unit 2, Algorithms and Programming, and which is worth 40%. And the Programming Project, which is worth 20%. You need to make sure you've got a folder. Inside your folder, you're going to need a copy of the PLC in front of each of the topics. Then all the work from the topics, with the exam questions that will complete throughout the different units, then the end of unit assessment, and then we'll complete a reassessment, a chance for you to improve on your grade. There's lots of different places you can go to get help. Craig and Dave are a series of videos that will talk you through each part of the specification. These are really good videos because they go into good depth, but you shouldn't just rely on them. Isaac Computer Science is made specifically for A-level computer science. It has information on each of the different topics in written format and should probably be your second place to go. There are also assessments on here which I will set you and I want you to complete at different times. There are other websites, but those top two are the ones that I'd recommend. If you haven't already done so, you need to get the code from me for our Isaac Computer Science and join our class. We will be completing 2 lessons of programming and 3 lessons of theory each week, but some weeks we'll swap that around when we need a little bit more of a focus on programming. Here's a quick overview of the course. You might want to pause this video to have a look at the different units that we're going to be completing. In theory, we're going to start looking at the structure and the functions of the processor. And this lesson will look at the ALU, the control unit, buses, and then we'll start going into registers. The first part of programming will be basic programming. Now, if you've done GCSE Computer Science and done Python before, you're going to find this easy and you're not going to have to attend all of the lessons. But those of you who have not, you're going to be expected to put in a lot of extra work outside of lessons to catch up. This is the book that I recommend buying if you want to buy a textbook. It's a PG Online one, and if you go online to PG Online, you can order this textbook. It is quite expensive, but if you prefer using a textbook for revision and work, this is probably the best one for you. I've created a digital classroom for you. You need to join my Google Classroom, and the code is on the screen in front of you, so you might want to pause the video and join my class. On there you'll find a lesson PowerPoint, an exam question with answers. Some lessons have walkthroughs, particularly with extended answers, the Craig and Dave video, and a link to the Isaac Computer Science notes. This is the content of the 3 different units. You'll see the theory unit is unit 1, the algorithms and programming unit is unit 2, although it's assessed with an exam paper and not through practical programming. However, you are going to have an advanced understanding of Python to complete this. And then finally, part 3, the programming project. This is where you're going to take an extended project over about 6 months, design it, and it's going to be on a project that you want to complete. So you can decide what the project's about. You're not going to be given that. You'll make it, evaluate it, test it, but I'll give you more information about that at some point. This is what our PLC looks like, a personal learning checklist. This should be at the front of each unit. It gives you a guide of what should be in each unit, what's going to be assessed, and what you need to know. And we're going to refer back to these throughout learning. There may be times that I ask you to do some flip learning. That will probably usually include a Craig and Dave video or a material that I'll give to you. This means I want you to watch and complete the work at home, come into class, and that's when I will answer any questions you have about the topic. You can identify any problems in your understanding, you'd make notes and bring those back to class. There's an emphasis in A-level on you being more independent. You're going to have to be taking notes at certain points, and this is the way that I suggest you do this, through cornel notes. These work with a title at the top and a date. So you might want to put the title, the unit that it's linked to, the specification point at the top, so they're easy to find. On the left hand side, your keywords or key questions that you need to know. These are best in a different colour or highlighted or underlined or any way that you want to do that. On the right hand side, you make your main notes. You might want to put abbreviations, key thoughts, anything that you think is important. Diagrams goes in this part. And the idea of the summary is that at the end of the lesson, you go away, you reflect on that work and summarise that into key learning at the bottom. Now this is a key skill. You're picking out the key information that you need to know and remember in a succinct way. From time to time, I will be doing folder checks, so that means you need to be bringing your folders with you to lesson. Those of you who completed GCSE will find there is quite a bit of a crossover with this course. However, on A level, it's more about the application. So you might be able to tell me what a CPU is, but it's actually applying it to a scenario that's the key point. That means you need to be able to evaluate the purposes and the uses of it and then apply it to that situation. So for a starter, I want you to try and identify these 4 components. Pause the video, see if you can write them down, and then I'll tell you the answer in a second. Okay, so you should have written those down now. Let's have a look. The first one is a CPU, and that's what we're going to be having a look at to start with. The second one is RAM, Random Access Memory. And this is a form of memory. The next one is ROM, Read-Only Memory. It does look a little bit different sometimes, and we're going to be looking at read-only memory in a future lesson. And the final one is a hard drive. So what is a CPU? This is a key question. It's a question that comes up quite regularly on exams. A CPU handles all instructions. That might be from input, output, memory, storage, etc. And it executes those instructions. Well, it doesn't actually execute them, it tells the computer or the different parts what to do. So you can think about it, a lot of people call it the brain of the computer. Well, actually, it's more like a calculator. You give it numbers, it calculates something and gives you a response or result, or executes a display to display a result. It's actually the software which has most of the functionality of the computer, and it's just the CPU which runs it. So the software has the majority of the complexity. So in summary, it handles all instructions and it executes them. So the CPU can also sometimes be called the processor. And inside the CPU, there are a number of different components. You should be given a sheet to go with this. If you haven't, draw this diagram in your notes, and then I want you to label the different parts of the diagram around it. Task 1 is shown on the next slide. At this point, I want you to get used to the different resources that I've provided you with. So go away and look at Isaac Computing or Craig and Dave, and around that diagram I want you to label the different parts of the CPU. I'm going to go through them shortly, but you should try and do that first. Once you've done that, watch the information that I'm going to give you and add to your notes anything that you might have missed. So buses are essentially a set of wires, parallel wires that connect different components on a computer. Now, we generally talk about 3 different buses, but if we're talking about buses overall, we call them the system bus. So these 3 buses make what we call the system bus. So in the exam, you might hear the system bus, and that includes the address bus, the data bus, and the control bus. 3 different buses. This is an abstracted view of the buses. You can see the system bus, all 3, they'd run parallel. You can see here they're connecting things such as the processor, the CPU, remember the processor is a different name for it, input and output devices, memory and storage. You can see our 3 different buses and how they work. They transmit information and data. The control bus is bidirectional, as is the data bus. The only bus that data travels one direction on it is the address bus. Now, it might be that it travels from the processor on the address bus to the input and output and to the memory. You can see that it's traveling almost in one direction from the processor out into those different parts of the computer. So remember, the control bus is bidirectional. That means signals are carried in both directions. The control bus basically transmits commands, timings, and status information between those different system components. Look at the terminology here. We need to be very clear on our terminology in A-level. The system components, remember, were the input and output devices and memory. The control bus might have a series of different types of requests. They might include a bus request. That's basically indicating that a device is requesting data. That might be an input or an output device requesting data so that a process can happen. There's a bus grant. It indicates the CPU has granted access to the data bus. So an input and output device might then have access to that data bus. Just imagine it's actually like a road. You can't have lots of different buses driving along it when there's only one track. You need to tell it, okay, you're free to pass. So think of it like a bit of a traffic light. It's allowing that input or output device to actually have access to that bus, the data bus in this case. You can do a memory read or write. So it can write that data into a certain memory location, or it can read it and carry that information on the data bus. So that if it's writing, it's taking the address where it's going to go. If it's collecting data or taking data to store in memory, it's going to use the data bus. There might be an interrupt request. Now we're going to come back to interrupts at a later point. An interrupt is stopping the CPU for a more important task. And then it's carrying clock signals. Remember, the clock is like a clock as we think it. It has a regular beat. Each beat is another fetch, decode, or execute instruction, and we'll look at those next lesson. And these synchronize the operations, and the control bus carries these signals. The data bus is a fairly simple bus. It's bidirectional, which means it can carry data in both ways. That could be from memory to the CPU, or it could be from the CPU to memory. It basically provides a track or road or path to move those data. So if we're going to store some data in memory, we might take it from an input and output device, and we might store it in memory. It moves data and instructions. Now in main memory, or in RAM, you've got a series of different locations which can store memory. We call these words. It's a fixed size part of memory. And the address bus transmits the address of where data or an instruction is stored. We're going to have a look at the structure of these with the opcodes and the operands at a later date. When an instruction has been performed, the result might be sent to a particular memory location through the data bus, and the address bus carries the address of where that data is going to be stored. So in summary, the control unit decodes instructions. It sends control signals to coordinate the movement of data through the processor, and it controls the buses. The buses, you've got three buses, remember, collectively known as the system bus. The control bus transmit control signals from the CU, the control unit, to parts of the processor. The data bus carries the actual data. Remember, both the control bus and the data bus are bidirectional. The address bus is one direction, and it carries the location of the register where the data is going to or coming from. You should now complete question 1 and question 2 of the exam questions. Then mark your answers and then try and improve them. Please make sure you use a different coloured pen when you improve them, and they then need to go in the folder right behind your notes.